One.
Okay. So are you clear with the concepts that I told you yesterday?
Yes, ma'am.
Okay. So today we will see the remaining part of basic terminology, and the first thing is object. So what is object basically? Can be a solid, can be a liquid, can be a gas. Any media is taken as an object. But in our light point of view, what is considered an object is it can be anything which gives out the light. Okay.
Ma'am, are you sharing screen, ma'am?
Okay. Just give me a minute. I think I have not shared the screen.
No, ma'am. I thought you were sharing it.
No, I actually forgot. Now I'm sharing the screen. Just wait a moment.
Okay.
Yeah, can you see the screen now?
Yes, ma'am.
Okay. So anything which gives out light rays, that is taken as what? That is taken as an object. Okay.
Yes,
So
ma'am.
it may itself give out the light rays, or it may give the reflected light rays. Whatever it is taken as the object. For suppose if you take sun, it gives the light on its own.
Yes, ma'am.
Okay. For suppose if I take the sun rays falling on an object, and this object is giving the reflected rays, these are the incident rays, then this is also taken as the object.
Yes, ma'am.
Okay, but here this is what kind of object? This is an object which is giving the light of somebody's, like it is giving the light of sun rays are falling on it, and reflected rays are given by it. Okay.
On its own, ma'am.
Yeah, not on its own. So anything which gives out the light rays, maybe its own, or maybe reflected, or maybe refracted by any kind of phenomena, if it gives the light, it is taken as an object. Okay. And there
Yes,
will be
ma'am.
two types of objects, as I told you yesterday. What are those? Point object and extended object.
Yes, ma'am.
So point object, extended objects, how did we make this classification? Depending on the size. Okay.
Yes, ma'am.
So if the size is very small, if it is, the pin size, if it is point size, like head of a small safety pin, so then it is said to be point object. We just represent it by dot. Extended object means it will have some height more than point size. Okay. And this
Yes.
is denoted by arrow mark.
Upward arrow. Yes.
Okay. So point object height will be, if I take height of the object, point object PO, it will be 0. If I take height of the extended object EVO, it will be some value, some height will be there. Okay.
Yes.
But not 0. Okay.
Yes.
Now we'll take what is image. So what is image? Basically image is the reflection of object. It's called replica, a replica of an object.
Yes, ma'am.
Like for suppose, I just see myself in a water. If I take a lake, or if I take a pond, if I look into the water, I can see my water image, right?
Yes, ma'am.
Like what it is showing, it is showing myself, right? So it's just a it's a just a copy of myself. So
Yes,
replica
ma'am.
of an object is nothing but what? Image. Similarly, if you look into the mirror, what mirror will show? Mirror will show you yourself only, right?
Yes,
So
ma'am.
it's what? It's copy paste of yourself. For suppose if you show pen, image is also of pen. If you show pencil, image is also pencil. So what it is actually copy paste of the object. So replica of the object is called what? Image. Okay.
Yes, ma'am.
And images will be of two types. Two types of images will be there. One is real image,
Virtual image.
and the other is virtual image. Okay. The answer is there in the heading itself. Real image, in the sense this image is formed by actual intersection of the rays. They really meet, they really intersect, and that is how image is formed. Virtual means they really don't meet. If you extend the rays backward, then they will meet.
Yes, ma'am.
Okay, so this topic is important. Differences between real image and virtual image. Are you clear with this?
Yes, ma'am.
Okay, then I'll tell you about the differences between real and virtual image. Differences between real image and virtual image. So if you take the first difference, so real image, how is it formed? It is formed by actual intersection of rays.
Yes, ma'am.
Actual intersection of rays. What rays? Maybe reflected rays or maybe refracted rays. Like if you take our present chapter reflection, we consider reflected rays intersection. If you consider next lesson refraction of light, there we consider intersection of refracted rays.
Yes.
Okay, so formed by actual intersection of maybe reflected rays or maybe refracted rays. So here we are talking about reflection, so I'll just mention reflected rays. Okay, now
Okay.
when you take virtual image, it is formed by intersection of reflected rays in brackets when they are extended backwards. When they are extended backwards, that means these rays actually they don't meet. If you want to make them meet, then what you have to do, you have to extend them in reverse direction, backward direction. Okay,
Yes, ma'am.
then they will meet. So the same point what we say is here the reflector rays appear to meet. Appear to means in reality they don't meet. అవి జస్ట్ మీట్ అయినట్టు కనిపిస్తాయి అంతే, బట్ యాక్చువల్గా మీట్ అవ్వవు. దే జస్ట్ అపియర్ టు మీట్. బట్ ఇన్ ద కేస్ ఆఫ్ రియల్ ఇమేజ్ వాట్ యాక్చువల్లీ దే మీట్.
Yes, ma'am.
Reflected rays actually meet at a point.
Ma'am, it can be caught on a screen, ma'am. It can be found on a screen.
Exactly. So actually meet in the sense you can catch it on the screen. So real image can be caught on screen. Okay, but here virtual image cannot be caught on screen. Cannot be caught on screen. Enduku? Because it is formed when you extend the rays backward. For suppose you are standing in front of mirror. So where will be your image? Your image will be inside the mirror.
Yes, ma'am.
So ఇది మనం ఎలా అజ్యూమ్ చేసుకుంటాం? We assume that rays are extended backward and in the backward direction they are meeting, and that is how image is appearing. సో ఇప్పుడు మిర్రర్ తీసుకుంటే నువ్వు అద్దం ముందర నిల్చుంటే ఏమవుతుంది? నీ నుంచి వచ్చే రేస్ అని అద్దం లోపల ఎక్స్టెండ్ చేస్తే మీట్ అవుతున్నాయి అని మనం ఒక అజంప్షన్ చేసుకుంటాం. కానీ
Yes.
ఈజ్ ఇట్ రియలీ పాసిబుల్ దట్ యూ గో ఇన్సైడ్ ద మిర్రర్ అండ్ యూ టచ్ ది పాయింట్? Not
No, no.
possible, no? So it cannot be caught on the screen. If you can go into backward direction, you can keep a screen and you can get it, but it's not possible to go in backward direction for us.
Yes, ma'am.
So you can't keep a screen and you can't get the image on the screen. Okay, so virtual image is also called unreal image because you cannot catch it on the screen. Okay,
Yes, ma'am.
now can we touch the real image? Yes, we can touch the real image because you are keeping a screen and on the screen you can touch. For suppose if you take movie theaters, they with the help of projector they project the light rays on the screen and you can see the cinema. Okay, so you can touch the screen, right? You can touch the image. For
Yes,
suppose
ma'am.
some Chiranjeevi is dancing on the cinema screen and you can touch the screen, it's possible. But when you take virtual image, can you touch the image?
No, ma'am.
No, you cannot touch. For suppose you take yourself, your image in a mirror, can you go inside the mirror and can you touch the image?
No, ma'am.
No, so you cannot touch the image. Okay, and what else is important? What kind of mirrors and lens will form the virtual image? See, in reflection we will study only about mirrors, Gautam. In refraction we will study about lens. Okay, in the case
Yes.
of reflection we study only about mirrors, so I'm just telling only with respect to mirror. What kind of mirrors will form the real image? Concave mirrors.
Yes,
Concave
ma'am.
mirror forms real image. And what kind of mirrors will form virtual image?
Convex.
Convex mirror. And concave mirror also will form, but only under one condition. Concave mirror will form virtual image only when object is between what? Between pole P,
And center.
pole and focus.
Focus. Yes, ma'am.
Between F and P. When object is between, if this is already completed in your school, you will get idea of this. If not, I'll tell you in coming classes what is pole, what is focus, what is this object between pole and focus, you will study a bit later. But remember this condition: convex mirror all the time it forms virtual image, and concave mirror 90% it forms real image. 10% case, like when object is between pole and focus point, then it will form virtual image.
Virtual. Yes, ma'am.
Okay, is this point clear?
Yes, ma'am.
Okay, now we'll go for pinhole camera. You have any idea about pinhole camera?
Yes, ma'am.
Yeah, what do you know about this?
Ma'am, the light ray comes from the top of the body and it get inverted, ma'am.
Okay, so what do we do in pinhole camera is we just take a box. Okay,
Yes,
so
ma'am.
let this be AB side, let this be CD side. Okay, so AB side, what we do is we just keep a small hole. Ma'am, why we can't keep big hole? If you ask me that question, if you keep a big hole, the image gets blurred.
Yes, ma'am.
Okay, if you keep small hole, image will be sharp. If you keep a big hole, what happens? Image will come in blurred way. Okay, so we have
Yes,
to
ma'am.
keep a small hole on AB side. So let this be small hole which is of pin size. So that's why it's called pinhole, because the size of the hole is small pin size. Okay, this is the
Yes,
hole. Okay, now the other side, CD side, what we do is we just
screen,
keep a
ma'am.
screen. Okay,
Yes, ma'am.
like ma'am, then why it is named as camera? If you want to take a photo of yourself, instead of screen on the CD side, what we do is we keep photographic film. Like photo studio people will do, no, they take a photo of us and they just wash it on photography film.
Yes,
Okay,
ma'am.
so instead of screen, if you keep photographic film, you will get your photo directly. That's why it's called camera.
Yes, ma'am.
But in our class we don't want any photo, we just want to understand the concept, so we take a screen on it. Okay,
Yes, ma'am.
so what we do, we just keep a source of object here. So I'm just taking an arrow mark. Maybe you can take a candle flame here. Okay,
Yes,
so
ma'am.
candle gives out the light, so I can take it as an object. Okay, now candle flame is having certain height, no? So what kind of object is this? Point object or extended object?
Extended.
Extended object, because it is having some height. Okay, so now what happens, I'll just take the top point, I'll take the bottom point, let it be P, let it be Q. Okay, ma'am, why are you not taking the wax part? Because wax is not a source of light, no?
Yes, ma'am.
Only the flame is a source of light. So flame will be the object here. PQ is the object here, not the entire candle. Okay, so the
Yes,
rays
ma'am.
which are coming from P, what do they do is they just pass through this hole and they just go in downward direction. Okay, because light travels in rectilinear way, no?
Yes, ma'am.
Similarly, if you take from Q, they just travel through this and they just go like this. Okay, man, why can't they go straight? They can go straight also. For suppose you take the rays which are going straight from P point, now are they entering the pinhole?
No, ma'am.
No, that is why we can't see them on the screen. Okay, so from Q point also they'll go in different directions, but all those rays are not passing through pinhole, no?
Yes, ma'am.
Ma'am, why are you taking only in slant direction, in bending direction? Means this is the reason. From every point the light will travel in all the directions, but we have hole in specific direction, right? So we
Yes.
consider the rays which are passing only through this hole. Okay, so these rays which are passing through the hole, what is happening? Top point, the rays from top point, they are reaching the bottom on the screen, so I'll take it as P dash. The rays from bottom point Q, they are reaching top point on the screen, so I'll take it as Q dash. Now this P dash Q dash is our image.
It is inverted.
It is inverted because top point P reaching down here. Instead of P dash Q dash, we are getting Q dash P dash. Okay, so
Yes, ma'am.
what is the nature of this image? The
Inverted.
image is inverted. Clear with this point?
Yes, ma'am.
Any doubt in this?
No, ma'am.
Okay, so this is your pinhole camera concept. You take an object, for a box you just keep hole on one side, the other side you keep a screen, and you have to observe from this direction. This is your eye, you will be observing from this direction so that you will be seeing the image. Okay, so this is
Yes.
how ulta will be the formation of image. Okay, if you want to really have the photograph, then what you have to do, the screen must be replaced by what? The screen must be replaced by photographic film. Okay,
Yes, ma'am.
if you keep photographic film that will be made up of silver bromide, silver chloride, then you will get image of yourself. And why are we not taking bigger hole? You will get
Image will be blurred.
blurred. Small hole gives clear image. If you take
Yes.
bigger hole, it will give blurred image. Okay,
Yes, ma'am.
now what if I take some 3 holes or 4 holes, I'll just increase the number of holes. If I take more
Multi-
number of,
Multiple reflection will take place.
there is no reflection at all here in pinhole camera. Where is the reflection? Tell me. The light rays are just passing
Mul-
through the hole.
Multiple images will be formed.
Multiple images form and there is no reflection in pinhole camera. Understand that point, Gautam. See,
Okay.
where is the reflection? The rays are just passing through the hole. Hole నుంచి just rays వెళ్ళిపోతూ ఉన్నాయి అంతే. అక్కడ ఎక్కడ రిఫ్లెక్షన్ జరిగింది?
Yes,
జరగలేదు
ma'am. No
కదా.
reflection.
జస్ట్ హోల్ నుంచి ఎంటర్ అవుతూ స్క్రీన్ మీదకి పడినాయి అంతే. అసలు అక్కడ మనకి ఎక్కడ మనకు రిఫ్లెక్షన్ అనేది జరిగింది? రిఫ్లెక్షన్ అంటే ఏం జరగాలి? దే హ్యావ్ టు ఫాల్ ఆన్ ది ఆబ్జెక్ట్ అండ్ దే హ్యావ్ టు రిఫ్లెక్ట్ బ్యాక్. They have to come back in the same direction, right?
Yes,
So
ma'am.
here the rays are not coming back.
Yes, ma'am.
So if you see here, this is the first incident ray. Where is it coming back? It is not coming back. It is just passing through the hole. So there is no
Yes.
reflection in pinhole camera. The rays are just passing and they are forming the image. Okay.
Yes, ma'am.
Any doubt in this? So
No
if you
doubt.
increase the number of holes, number of images also increase. And what else is missing? Yeah, and pinhole camera, you can also use this for proving the straight line path of the light rays. Like if you see the rays are traveling in straight line, right? So this
Yes.
indirectly proves the rectilinear propagation of light rays. Now we need to discuss one more thing about the nature of the image. It is ulta, so inverted. Okay. Now where is
Yes.
this image? It is on the screen itself, right? So you are getting on
Yes,
the
ma'am.
screen itself. So will it be real image or virtual image?
Real image.
It will be real image. Okay. So I just
Yes.
drew the diagram in a rough way, but when you see it in really, the size will be less for image. So it will be diminished. That means if you compare the height of the object, height of the image height will be small. Okay.
Real.
Diminished means HI, that means height of the image, will be less. HO, that means height of the object. Image height will
Yes.
be less compared to height of the object. In diagram, it looks bigger, Gautam. It was just a rough diagram, but when you see in reality, it will be less. Okay.
Yes, ma'am.
Height of the image will be small. Any doubt in this?
No, no doubt.
Okay. Will there be any reflection in pinhole camera?
No, ma'am.
Okay. Just passing through the hole. That's it. Okay.
Okay, ma'am.
Now we'll see some important terminology related to reflection. Okay. So first we'll see what is reflection phenomena and then we'll see important terminologies. So what is this reflection, Gautam? It is a phenomena in which the light rays after falling on an object, after falling on an object, get reflected back. Reflected back in the sense what?
Comes back.
Yeah, come back. Reflected back into the same medium. Medium in the sense from which place they have entered, they'll get back into the same place. Okay. For
Yes, ma'am.
suppose they are entering from air, again they'll get back into air. If they are entering from water, they'll get back into water. That's the meaning of that. Okay. So it's a
Yes, ma'am.
phenomena in which the light rays after falling on an object, they get reflected back, come back into the same medium. Okay. So what does it mean? If they don't fall on an object, they don't get reflected, right? If
Yes,
there
ma'am.
is no obstacle, if there is no object, they just go see that. I mean they just go like that. If there is any obstructor, if there is any object in its path, then they get reflected back. Okay.
Yes,
So
ma'am.
what we do is, let me take this as an object. So we just quote the object like this. This is object. And object we consider two sides, Gautam, okay? So this is side 1 and this is side 2, okay? So side 2, I just crossed these lines, right? You can see some lines crossed over on side 2. What does it mean is, it is non-reflecting side. If you keep
Yes.
those lines, no, it means it is non-reflecting side. That means when light rays fall on the side 2, there won't be any reflection. That is the meaning of it.
Yes, ma'am.
ఈ లైన్స్ ఏవైతే పెట్టినామో దాని మీద లైట్ పన్నా కూడా రిఫ్లెక్ట్ అవ్వదు అనమాట. దట్ ఈస్ ద మీనింగ్ ఆఫ్ నాన్ రిఫ్లెక్టింగ్ సైడ్. అండ్ వాట్ ఈస్ సైడ్ 1? సైడ్ 1 ఈజ్ రిఫ్లెక్టింగ్ సైడ్. అంటే
Yes, ma'am.
the light rays, when they fall on it, they undergo reflection. Okay,
Yes, ma'am.
now let me take a light ray. So it's falling on the reflecting side of the object. Now the light ray which is falling, what do we call it, Gautam? This is
Incident.
called incident ray. And how do we denote it? IR. Okay, now it is striking the object at one point, right? What is this point called? That is called point of incidence. It is denoted as what? In your textbook it was O. Okay, fine. Okay, so this is called point of incidence, the point where light is falling. Okay, now
Yes.
so after falling on the reflecting surface, what happens to it? It will come back into the same media but in different direction. Not
Yes,
in the
ma'am.
same direction but in different direction. Now what is this called? The ray which is coming after reflection, this is called reflected ray. It is denoted as RR. Okay,
Yes, ma'am.
any doubt so far?
No doubts, ma'am.
What is point of incidence? This is a point where incident ray is falling. What is
Yes, ma'am.
incident ray? The rays which are falling on the object. What is
Yes.
reflected ray? The rays which are coming after the reflection process. Okay,
Yes, ma'am.
now at the point of incidence, you have to construct a perpendicular. See, tell me, where is the point of incidence? It is on the horizontal line, right? Object is
Yes.
kept horizontal. Object is in horizontal position, right?
Yes, ma'am.
So now if you want to construct a perpendicular, how must be the line? Will it be vertical or will it be horizontal again?
Horizontal. Vertical. I'm sorry.
Vertical. I need a perpendicular. Perpendicular means what will be the angle?
90 degrees.
90 degrees. So at this point O, I just keep one vertical line. Okay, dotted line. What is this called? This is called normal line.
It is imaginary.
Yeah, imagine. Normal means what? Perpendicular. Angle will be 90 degrees. Between what? Between the normal and horizontal. That angle will be 90 degrees. Okay.
Yes.
Now, so what is this imaginary line passing through the point of incidence and making 90 degrees angle? You have to construct a perpendicular at the point of incidence. This perpendicular line is called what? Normal. Okay.
Yes. Yes, ma'am.
Now, between normal and the incident ray, there is some gap, right? Angular gap.
Yes, ma'am.
What is this called? Angle of incidence I.
Yes, ma'am.
Similarly, between normal and reflected ray also there is some angular gap. This is called angle of reflection R.
Yes, ma'am.
Any doubt in this?
No doubt.
Okay. Now, between the incident ray and between the mirror, there is some gap. What is this called? This is called glancing angle of incidence, so GI. G means glancing angle. This is for incident ray, so glancing angle of incidence.
Yes, ma'am.
Similarly, when you take the gap between reflected ray and the mirror, this is also called glancing angle, but this is for reflected ray, so glancing angle of reflection GR.
Yes, ma'am.
Any doubt in this?
No doubt, ma'am.
Angle of incidence means angle between incident ray and normal. Glancing angle of incidence ray means incident ray and mirror.
Yes, ma'am.
Okay. Now, just tell me one thing. If there is no object, Gautam, what could be the direction of incident ray? Will it take any bends or will it go straight?
It will go straight, ma'am.
So I can say that this is the path if there is no object, right?
Yes, ma'am.
So this is called actual path of incident ray.
Angle, yes, ma'am. Angle of deviation.
Very good. This is actual path of IR. That means if there is no obstructor, if there is no mirror, it could have gone in the same path. This is actual path of incident ray. Because of the presence of the object, it is undergoing some deviation. and it is going in the path of reflected ray. So the angle between this reflected ray and the actual path of incident ray, what is this called? Angle of deviation D.
Yes, ma'am.
Any doubt?
No doubt.
All clear?
Yes, ma'am.
Now we'll see the terminologies. Okay, I'll just write one by one now. I'm sharing you the video link now. It is public, you can see it. Okay, yesterday I
Okay.
kept it private by mistake. Okay, now if anywhere if you get a doubt, there is no need to ask me again. If you see it, you'll understand. Okay,
Okay.
so
Okay.
first one, incident ray. So tell me, what is the definition of incident ray?
Ma'am, a ray of light which falls on the reflecting surface. Ma'am.
Yeah, yes, the ray which falls on the mirror or
Yes, ma'am.
reflecting surface, anything in fine. How do we represent it? We represent it as IR. Okay, now what is reflector ray?
The light ray obtained after reflection from the surface, ma'am, in the same medium.
Yeah, the ray after reflection.
From the surface.
Yeah, the ray after reflection from the mirror. After reflection, the ray obtained after reflection, okay, from the mirror. That is your reflector ray. This is RR. Okay,
Yes, ma'am. Ma'am, in the same medium.
yeah, it will be in the same medium. Okay, incident ray, reflected ray, normal, all will be in the same medium. Okay,
Yes, ma'am.
and third one is point of incidence.
It is a point where the incident ray strikes, ma'am.
It is denoted with O. Yeah, the point at which
The incident ray strikes.
IR strikes. IR means incident ray. The point
Yes.
at which incident ray strikes, that is your point of incidence. And number 4, angle of incidence.
The angle made by the incident ray and the normal.
The angle made by the incident ray with the normal.
With the normal.
With the
Okay.
normal. Okay, when you use the word by the incident ray, you have to mention with the normal. Okay,
Okay.
so this is the angle made by incident ray IR with the
Normal.
normal. Now fifth one, angle of reflection. So what is angle of reflection?
Angle made by reflected ray with the normal.
Very good. So angle made by reflected ray RR with the normal. Okay, so any doubt in these definitions?
Oh.
Okay, now next terminology is normal. So what is normal? Normal is denoted by n dash. Generally n dash. First end n, the other end n dash. In your textbook it is given as on. Anything is fine, Gautam. Okay,
Okay.
I'm telling you the standard terminology, like whatever is given in textbook, that is also okay. Okay, now
Okay.
what is this normal? It is the perpendicular drawn at the point of incidence. Drawn at the point of incidence, that is your normal. Okay,
Yes, ma'am.
that means what does it mean? Basically it means that the angle between normal line and the mirror will be how much?
90 degree.
Very good, it will be 90 degrees. Now next definition is what? Glancing angle of incidence.
Yes, ma'am.
Glancing
Angle made
angle.
by incident ray and the reflecting surface.
Angle made by the incident ray under the reflecting surface
Yes, ma'am.
with the reflecting surface. Or else you can say angle between incident ray and reflecting surface. If you say
Okay.
angle made by incident ray, then you have to say with the reflecting surface. That angle is made by incident ray, but with whom? But with the reflecting surface. Okay,
Yes, ma'am.
so this is angle. If you say angle between, then and is fine. Angle between incident ray IR and mirror. That means reflecting surface. Okay.
Yes, ma'am.
Next is glancing angle of reflection.
The angle
Glancing.
between reflecting surface and the reflected ray, ma'am.
Very good. Okay. So this is denoted as GR. So this is angle between reflected ray RR and the reflecting surface, that means mirror. Okay.
Yes, ma'am.
Next one is what? Angle of deviation. In your textbook it is denoted as delta, but
Yes,
generally
ma'am.
it is taken as D also. Anything is fine. Okay.
Yes, ma'am.
D, sometimes it is also taken as delta.
Yes, ma'am.
So what is
The,
this angle?
the angle between the direction of incident ray and the reflected ray.
Yeah, angle between reflected ray and actual path of incident ray. And actual path of incident ray. Okay.
Yes, ma'am.
So any doubt so far?
No, no doubt, ma'am.
Okay, fine. Are you clear with reflection phenomena?
Yes, ma'am. Reflection. Yes, ma'am.
Okay. Now, okay. So this is our reflecting this is your object, which means mirror. Okay. So
Yes,
this
ma'am.
side is your reflecting side RS. This is your non-reflecting side NRS. And this is your mirror. Okay.
Yes, ma'am.
See, generally, like if you take reflecting side, there are certain things that you need to understand. If the reflecting side is polished, or if the reflecting side is very smooth, or if the reflecting side is very much regular, that means ఏమంటారు? I mean, there are no depressions.
Yes, ma'am.
If it is flat, then reflection will be very much high. In all these cases, you will have more reflection.
More reflection. Yes,
Yeah,
ma'am.
more amount of light will be reflected when the reflecting side is polished, or if it is smooth, or if it is regular. And even if it is shiny surfaces also will do more reflection. Okay.
Like diamond. Yes, ma'am.
Yeah,
Multiple. Yes,
yeah.
more.
So more reflection in the sense, all these kind of objects like which are shiny, which are polished, which are smooth, these kind of objects, what do we call them? They are called best reflectors of light. Best reflectors. Why is it so? Because they reflect most of the light, no?
Yes, ma'am.
Okay. If you take other cases like irregular objects which are very rough, unpolished, very dull in look, they are bad reflectors of light. Okay.
Yes,
So
ma'am.
for reflection, generally which do we consider, which is better? Best reflectors or bad reflectors?
Best reflector.
Best reflectors are better. Okay. Now we'll see loss of reflection. Now you have any idea about loss of reflection?
Yes, ma'am.
Yeah, what do you know about loss of reflection?
Ma'am, angle I is equal to angle R, ma'am.
Yeah, so when you take loss of reflection, so we'll just take the diagram once again. This is RS reflecting side, this is NRS non-reflecting side, this is mirror MM dash. Okay.
Yes,
Now
ma'am.
let me consider this as the point of incidence O, and at the point of incidence we'll take a normal, we'll take it as N dash. Okay.
Yes, ma'am.
Now this is the incident ray, and this is the reflected ray. This is IR, this is RR, and this is the angle of incidence, this is the angle of reflection. So the first law says that angle of incidence will be equal to angle of reflection, and second law states that incident ray, reflected ray,
And
and
normal
normal end and dash all will lie
lie
in the same
plane.
plane. All will lie in the same
Plane.
plane. Okay. And third one, like if angle of incidence is 0, then angle of reflection is also what?
Zero.
0. In that case, then incident ray, reflected ray, both will lie on normal. See, this is the angle of incidence, this is the gap, right? This is the gap. This gap is angle of incidence. If it is 0, what does it mean? The incident ray comes closer to normal, right?
Yes, ma'am.
If incidence angle is 0, angle of reflection is also 0, then reflected ray also comes closer to normal.
Yes, ma'am.
I value 0 in the sense what? There is no gap between incident ray and normal.
Yes, ma'am.
యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ 0 ఉంది, రిఫ్లెక్షన్ యాంగిల్ 0 ఉంది అంటే అసలు ఆ రేస్కి నార్మల్కి మధ్య గ్యాపే లేదని. గ్యాప్ లేదంటే ఏమవుతుంది? ఇన్సిడెంట్ రే రిఫ్లెక్టెడ్ రే రెండు కూడా నార్మల్ మీదనే ఉంటాయి. ఓకే,
Yes, ma'am.
దెన్ డయాగ్రామ్ విల్ బి లైక్ దిస్: రిఫ్లెక్టింగ్ సైడ్, నాన్ రిఫ్లెక్టింగ్ సైడ్. సో this is your normal n dash. So then incident ray will be like this. It is falling on the mirror through the normal. Reflected ray కూడా ఇట్లానే ఉంటుంది. అంటే గ్యాప్
Yeah.
ఉండదు. If angle of incidence is 0, then there is no gap between incident ray and reflected ray and normal.
Yeah.
So both will be
Yes.
on the same plane, same normal. Okay,
Yes, ma'am.
so any doubt so far, Gautam?
No doubts, ma'am. Clear.
Okay, then I'll tell you one more last concept, then I'll wind up the class. Okay,
Okay.
I'm taking 40 minutes class now. Tomorrow I'll take extra 20 minutes. Okay,
Okay, ma'am.
so then next one is Fermat's principle. So Fermat is a name of a chemist, Gautam. Okay, so in ఏం చెప్పిండు అంటే, if you show different directions, if you show different paths for light, light will choose the smallest path. For suppose నువ్వే ఉన్నావు గౌతమ్, నువ్వు ఇక్కడ ఉన్నావు, ఇది నీ స్కూలు. ఓకే, సో యు ఆర్ హ్యావింగ్ డిఫరెంట్ పాత్స్. సో ఫస్ట్ పాత్ విల్ టేక్ 5 kilometers distance, second path will consume 15 kilometers distance. Which will you decide?
5
kilometers. So everybody prefers the shortest path, right? Similarly, Fermat said that if you show different paths, light ki manam different paths ఇచ్చినప్పుడు, what will light do? It selects the path which takes the least time to travel. So light chooses the path which takes
Less time.
least time to travel. Okay, I'll give you one more example, Gautam. This is you, this is your office. You have started at maybe 7 a.m. in the morning. You have to be in the office by 8 a.m. Okay, so
Yes,
first
ma'am.
path 5 kilometers distance but heavy traffic. Okay, and second path 15 kilometers distance, but here it just take only 40 minutes time because there is no traffic. Now in this case, which path will you choose?
15 kilometers.
15 kilometers. అంటే ఇక్కడ డిస్టెన్స్ మాత్రమే కాదు మనం కన్సిడర్ చేయాల్సింది, ద వన్ విచ్ టేక్స్ లీస్ట్ టైం, దట్ ఈస్ ఇంపార్టెంట్. కొన్నిసార్లు డిస్టెన్స్ తక్కువ ఉన్నది తక్కువ టైం తీసుకుంటుంది, కొన్నిసార్లు డిస్టెన్స్ తక్కువ ఉన్న ట్రాఫిక్ వల్ల ఎక్కువ తీసుకుంటుంది. So the same case here, when you take the light, different paths are available, but which path will be selected by the light? The one which takes the least time to travel. ఓకే, సో డెరివేషన్స్ ఉన్నాయి నీ బుక్లో, అది అవసరం లేదు ఎందుకంటే నీకు ఎగ్జామ్ డెరివేషన్స్ అడుగుతారా నీకు ఎగ్జామ్?
Subject, object.
Only objective. So I just don't want to waste the time by discussing the derivations. I'll tell you the concept, exam point of view. Okay.
Okay.
So is this clear? Fermat principle.
Yes,
Light
ma'am.
chooses a path which takes least time to travel. Okay. Yeah.
Okay, ma'am.
So this is what for today, Gautam. Tomorrow I'll take extra 20 minutes time. And tomorrow, is it okay if I take the class in the morning?
Yes, ma'am. No problem.
Maybe morning 7 to 8:30 like that I'll take.
No problem.
Okay,
Yes.
7 to 8:20 I'll take. Okay.
Okay.
Bye, beta.
I mean, you will send link morning, sir.
I'll send you the link in 1 hour because it takes time to get uploaded. So I'll
Yes,
send
ma'am.
you the link in 1 hour. Okay.
Okay.
Bye, beta.
Thank you.
Bye.
Thank you.